Water pollution. Types and sources of water pollution. 1. Types of water pollution: chemical pollution, contaminants like heavy metals, pesticides, and industrial chemicals; biological pollution, pathogens like bacteria, viruses, and protozoa; physical pollution, changes in water temperature, turbidity, and color; nutrient pollution, excessive nutrients such as nitrates and phosphates leading to eutrophication; thermal pollution, elevated water temperatures due to industrial discharges. 2. Sources of water pollution: point sources, direct discharges from industrial facilities, wastewater treatment plants, and sewage outfalls; non-point sources, runoff from agricultural fields, urban areas, and mining sites. So let's talk about the impact of water pollution. First, let's discuss the impact on humans. Water pollution can lead to waterborne diseases like cholera, dysentery, and hepatitis. Moreover, exposure to toxic chemicals can result in serious health issues such as cancer and reproductive problems. And of course, there's the reduced availability of safe drinking water, which is a growing concern. Now, moving on to plants, water pollution can cause significant damage to aquatic plants due to toxic chemicals. It can also lead to altered growth patterns because of nutrient imbalances. Additionally, turbidity in the water can reduce photosynthesis, further impacting plant health. Animals are significantly affected by water pollution. Fish kills often occur due to oxygen depletion, a process known as eutrophication. Additionally, toxins can bioaccumulate in aquatic food chains, posing serious health risks. Habitat loss and reduced biodiversity are also major concerns. Measurement of water quality parameters is essential for understanding and managing water pollution. Sampling and analysis of water involves several key parameters. pH measures acidity or alkalinity using pH meters or indicators. Electrical conductivity, or EC, indicates the total ionic content using conductivity meters. Turbidity measures water clarity using turbidimeters. Total dissolved solids, or TDS, quantifies dissolved solids using gravimetric methods, or TDS meters. Hardness measures calcium and magnesium content using titration. Chlorides are determined using silver nitrate titration. Salinity measures salt content using salinity meters or conductivity. Dissolved oxygen, or DO, measures oxygen levels using DO meters or the Winkler method. Biochemical oxygen demand, or BOD, measures organic matter biodegradability over 5 days using DO analysis. Chemical oxygen demand, or CARD, measures oxidizable organic and inorganic matter using dichromate oxidation. Nitrates are determined using spectrophotometry or ion-selective electrodes. Phosphates are measured using colorimetric methods. Sulfates are determined using gravimetric or turbidimetric methods. Heavy metals are analyzed using atomic absorption spectroscopy, or AAS, or inductively coupled plasma, or ICP. Organic contaminants are measured using gas chromatography, GC, or high-performance liquid chromatography, HPLC. Microbiological analysis. Most probable number, or MPN, estimates bacterial concentration, particularly coliforms, using multiple tube fermentation techniques. Indian Standards for Drinking Water, IS 10500, 2012, specifies permissible limits for various physical, chemical, and microbiological parameters to ensure safe drinking water. These parameters include pH, turbidity, TDS, hardness, chlorides, nitrates, fluoride, heavy metals, and microbiological contaminants. Drinking water treatment. Coagulation and flocculation. Coagulation involves the addition of coagulants, such as alum, to destabilize suspended particles. Then, flocculation follows, which is the gentle mixing process that helps form larger aggregates, known as flocks, from these destabilized particles. Sedimentation. This process allows flocks to settle under gravity in sedimentation tanks, effectively removing suspended solids from the water. Filtration. Here, water is passed through filters made of materials like sand, gravel, and activated carbon to remove any remaining particles and impurities. Disinfection. This process kills pathogens using chlorine, ozone, or UV radiation. Softening. It removes hardness, specifically calcium and magnesium, using ion exchange resins or lime soda ash treatment. Wastewater treatment. Primary treatment. Screening involves the removal of large debris, those big pieces that can clog up the system, and then there's sedimentation, where suspended solids settle down. It's a crucial step in treating water. Secondary treatment. Biological processes use microorganisms to degrade organic matter. This includes methods like the activated sludge process, trickling filters, or biotowers. Advanced or tertiary treatment. Chemical and physical processes are employed to remove residual contaminants, nutrients, and pathogens. Techniques such as filtration, adsorption, advanced oxidation, and membrane technologies are used. Common Effluent Treatment Plant, or CETP. This is a centralized treatment facility for wastewater from multiple small and medium-scale industries. It includes primary, secondary, and tertiary treatment processes to meet regulatory discharge standards. Effective water pollution control and treatment strategies are essential to protect public health, preserve ecosystems, and ensure sustainable water resources.